Infineon, we as a semiconductor company, we play here a key role from energy generation to the car is driving.
So you want to accelerate but decelerate again, and therefore we need semiconductors which are efficient in generating mode, so taking the energy from the wheel back to the battery.
Hi folks, this is Fabian and you are listening to Podcast4Engineers, the podcast you just have to listen to if you're interested in what's going on in the semiconductor market. Today's episode, we have two special guests and we are talking about EV, electric vehicles, what's going on in the market. Two guests, one is Dirk Geiger, the other is Christoph Bauer. Please introduce yourself.
Hi Fabian. Thanks for having me here on the podcast. My name is Dirk. I'm taking care as application marketing and management for the electric drivetrain, namely the traction inverter, the onboard charger, and the high-volt DC-DC application.
Yeah, thank you. My name is Christoph Bauer. I'm Global System Architect Level 1, so I'm just caring about the main inverter and therefore the technical point of it.
Perfect. And our topic is, in this episode, electric vehicles. Everybody's talking about electrification. So what is this? Why do we need it?
That's a very good question, Fabian. Electrification helps us to decarbonize our environment. It's really essential for our future to not burning fossil fuels anymore, but electrify our mobility, the transportation sector. The goal of the industry is that every second car in the industry is sold in 2030 in electric. So it's really essential. It provides a fast-growing environment to us. And I think Christoph came here by car this morning with an electric car, right?
Exactly.
And I think it's not only the decarbonization, but it's also the fun to drive factor. If you sit in such a car and feel the acceleration, but also the quietness, that is really an experience. So it's also us, the consumer, that are interested in that.
Okay, sounds like fun. I had a pleasure to drive electric vehicles before, and I can totally subscribe to this. Mm-hmm. But we are not talking about passenger vehicles only. There's more to electrify, isn't there?
Absolutely, absolutely. So passenger vehicle certainly is in everybody's name because that's where we have a touch and feel with it. That's our daily life, coming by car, going to work or going shopping. But it's also the transportation sector, the trucks and buses. So public buses already, there's a big portion already electrified. The next step is getting the long-haul trucks, so the big trucks on the highways, electrified. That's certainly not that easy and has other challenges than a passenger vehicle, but it's on the way. There are first trucks on the road already electric. And on the other end on the spectrum, there are the so-called light electric vehicles. That's the two-wheelers, the three-wheelers that getting electrified. Maybe not so popular here in our Western world in Europe, but if you look into India or China, there is such a huge population of two-wheelers. Electrifying that, if you have been to Delhi with the smog and the air, you will be happy that that gets electrified, I tell you.
So what is needed to convince us, the consumers, to, step into that electrification? What can the industry do?
Well, there's a lot of things to do. So we need to understand what is needed. So we need an infrastructure for that, for example, to charge the electric vehicles. We are at the very beginning of this life cycle, of a sustainable life cycle. Means the cars that get produced, there will be a second life, there will be recycling, and then it flows again into the cycle. And in this cycle, we are just at the beginning. So we need to be very careful with our raw materials, how we use them, how we build our cars, not to heavy, use a material that is available in very sustainable ways.
Christoph, anything to add there?
Exactly. Yeah. What I wanted to add here is, so if you look from a combustion engine point of view, then we are always talking about efficiency, and this is more or less how many kilometers I can get per 1 liter of diesel. And of course, as more efficient I am, as less I have to pay. That's quite clear. In an electric car, it's a bit more, it has multi-dimensions, as I said. So if we have more efficiency, of course, we can drive longer with the same battery. But as Dirk, as you said, if we want to get a worldwide electric vehicle fleet, then we have to think about if we just keep the range constant to 300, 400 kilometers, if we get efficient cars, then we can have smaller batteries, and of course then we have to get less amount of lithium and so on, and everything that, which is maybe very good if we avoid just to bring so much material into this. And that's the reason why we as Infineon, we have our vision of 10 kilowatt hours per 100 kilometers. That means cars should be efficient, not just that the consumer can drive, but that the complete, let's say, overall idea makes sense.
So we're talking about the market, about the developments, and where's Infineon's role in this picture?
Oh, in Infineon, we as a semiconductor company, we play here a key role from energy generation to the car is driving. Yeah? So we support the green energy production like windmills or solar chargers or solar generations. We transport or help to transport the energy from A to B to a charging station, and then we can charge or help to charge the electric vehicle with a AC to DC or DC fast charging. And that also I need to extend a little bit to what Christoph said before. It's not only the car, it's also the infrastructure and the connection of that car to the infrastructure. So there's a word, smart charging, means how to integrate the vehicle into this charging environment. I think that's also a key factor. So in all these aspects, Infineon really helps this industry to develop these leading applications in high efficient power conversions.
One aspect obviously also is the drivetrain, Christoph.
Yeah, exactly. So one example I think it's very easy to point out is the onboard charger. Every car has it, but of course there could be unidirectional, so it's just taking energy from the grid into the car, but it can be bidirectional. Of course, Infineon has components for that. And as, for example, in the main inverter, the complete power from the battery to the motor is transferred. Yeah, so there really the energy efficiency can be made. And of course, we have components that are quite efficient in motoring mode, so driving. But of course, if we just think about not just driving 130 kilometers per hour on the Autobahn, but being in a traffic jam in Munich, right? It's quite common that you're in a traffic jam. So you want to accelerate, but decelerate again. And therefore, we need semiconductors which are efficient in generating mode. So taking the energy from the wheel back to the battery. Yeah. And if you are able to do the cycle, so accelerating the car, braking the car, if you are able to do this very efficient, then we can make the battery smaller, we can make the vehicle cheaper at the end. And I think that's the goal, and that's what the customer, of course, makes it more attractive if we have cars which are not so expensive, because we don't need the huge batteries.
Yeah, so a word which I've heard many times from both of you, Dirk and Christoph, is efficiency. Where are we at the moment, and where do we need to go?
Yeah, that's Christoph already started to elaborate on that. So today, a typical EV uses about 15 to 20 kilowatt hours of energy for 100 kilometers. Yeah, so that's a measure how you, like in the combustion engine, you said how many fuel consumption per 100 kilometer. Here we talk about kilowatt hours for 100 kilometer. The target is, or our vision is, to get to 10 kilowatt hours for 100 kilometer.
Oh, okay.
That's another 60% of improvement.
Challenging.
Absolutely challenging. It's not straightforward, not that easy, and we need to take all aspects into considerations. Like, for example, Christoph mentioned making this battery smaller by having more efficient drivetrain. That also helps to reduce the weight of a vehicle. Yeah, and lighter vehicles help to be more efficient in driving and accelerating.
Okay, so what are Infineon's solution then with regards to this efficiency? What are, obviously also you've mentioned this, maybe we can get a little more into that. What are the key applications in an electric vehicle?
Yeah, I think the traction inverter certainly plays the key role in electric drivetrain. Christoph can talk about that in a little bit more detail.
Yeah, So I think so we are targeting two directions. So one is the direct efficiency, let's say, so the power semiconductors for really transferring this 100, 150 kilowatts, what you have on your car to really make this transition in both directions very efficient. So there are silicon dies, silicon carbide dies, and of course we can later on talk maybe a bit of gallium nitride, which is, and of course the packaging is very important. So if you do a packaging, you can allow more efficiency. The second thing is we have weight, as Dirk said before, but we have of course size, because if you have, if your inverter, for example, is like shoebox size, if you can shrink it, you can shrink the battery, for example, and you can make your aerodynamics better. Because if you are driving 130 kilometers per hour or more, then the losses of the drivetrain gets less dominant, but it's really just the air drag. So if we help to make everything smaller, and therefore, for example, we are developing a chip which is combining different things. For example, like the power supply of our microcontroller together with the safety, because safety is very important. Within microseconds, there has to be the right decisions has to be made.
Obviously, yes.
Yes, to that everything is safe in each condition. So we are trying to combine everything and make highly integration, and therefore we can make everything smaller. And that's another intrusion point from ourselves.
So
I think that's a key aspect. So it's not only the power switches, it's a whole bill of material. So the chipset that enables power dense, high efficient applications. So you need the microcontroller, you need a sensor, you need a gate driver. I think we as Infineon, we have the benefit to offer all of that to our customers. And that provides us, in the other side, the understanding of the system and help to develop the next generation of products even more specific to that application.
Maybe one example how even it goes down into software, right? So of course we need the software to regulate and everything, that's clear. But just an example. So in order to make efficient torque management, to get the right torque to the wheel, you need to know the temperature of the rotor of the electric motor. But the rotor is turning with 80,000 RPMs, right? You cannot make a sensor inside or something like that. So what we are doing, we're having now in our new TC4 microcontroller, we have a parallel processing unit. That means we can have very, very complex thermal models running in this parallel processing unit that you can estimate very, very accurate with a very small timestamp the temperature in the rotor, and then you know what kind of currents you need and so on to do that.
Makes sense, yeah.
And another addition is, of course, motors without permanent magnets. I think that's a very huge trend. Infineon is supporting here with the excitation, so the magnets are replaced by coils, and of course we are delivering the power supplies or the excitation circuit for these coils, so that we can have in future more motors with less amount of permanent magnets. And of course, the nice thing is you can demagnetize, so you can remove the magnetic field, and then you are in sailing, so you don't need a clutch anymore. And this of course gives us efficiency again. So that's adding up at solving several points, let's say.
I would like to come back to the inverter topic. You've mentioned SiC, you mentioned silicon. So what is mainstream? What is the industry using right now, and where are we going to?
That's a good question. Not that easy to answer. I think in general it's a complementary setup today. So we will see all technologies in the field in parallel, depending on their needs. So, and what I mean about technology is silicon carbide, and in the future gallium nitride. Each of those technologies does have their benefit. So being cost efficient, being super efficient, or supporting power density with higher switching frequencies, and for that reducing the size of the passives and magnetics. So we always need to have a system understanding to find the sweet spot of each technology for that specific application and use case. That's key. And it's not one replacing the other. It's finding the sweet spot for each.
Maybe we can go for the example of the fusion or hybrid inverter. I think that's a very good point with the show. So we have silicon, which is not so expensive and very efficient at high power. We have silicon carbide, which is very expensive, but very efficient at low power. And if we're now looking at a car, a normal car, let's say 150, 200 kilowatts, in a normal drive cycle, it's just normally you don't just need 80 kilowatts for driving in the very most of the cases. So now you could make now a car with silicon carbide highly efficient for 200 kilowatts, but you normally use 80 kilowatts.
Yeah.
Doesn't make sense from a cost efficiency point of view. So what is now a very good trend, and Infineon is supporting that, is that we say, let's make the 80 kilowatts we are using very often, and we need very efficient, let's make them out of silicon carbide and make in hard parallel the silicon for the fun, let's say, right? And then we have a good trade-off. We are not, let's say, losing much efficiency, but we have a more price attractive thing. And we, of course, can get more cars out there which are efficient in the range where they're driven.
Yeah.
Because that's important. It's not important that the cars with high power are just efficient. We need that the majority of the people can drive efficiently.
And I think that comes back to my very first statement: circular life cycle, sustainable. So we can build more cars with the same material as of today.
Exactly.
Efficiently.
So did I hear correctly? You are combining silicon and silicon carbide. Is that correct?
Yeah, it's hot paralleling of them.
Okay.
So you really parallel a silicon and a silicon carbide switch, and you can either switch them exactly parallel, or you can switch them independently. Depends on what strategy you mean. You can get more benefits.
We call this fusion technology.
Okay.
That's our term for it. If you talk with Infineon, you hear that quite often. Christoph explained that on the traction inverter, same thing.
Yep.
For the onboard charger, for example, where you can also mix technologies. In a 3-phase onboard charger, for example, you can have one super efficient phase you typically use when charging your car. So typical 3.6 kilowatt, for example, do it with silicon carbide, super efficient. And the other ones, which you seldomly use, the other 7.2 kilowatts, you can do with silicon. Good enough. And it helps you during your vacation to have the performance you need.
Yep.
During the daily life, you have the efficiency you need. So it's really nice to have this fusion technology coming to the market.
So the electrification of vehicles actually drives innovation. Is that correct? Can we say that?
Absolutely, absolutely. So there's a lot of innovation going on, not only by technology, but also EE architectures that drive innovation. Yeah? The other example is with modern EE architectures, zonal architectures, for example, there are new requirements emerging. Yeah? You have dependabilities between applications. You have functional safety requirements for high volt to low volt DC-DC converter. Yeah? Imagine your power steering is operated by a high volt battery, so you eliminate the 12 volt, or only have a 48 volt network, for example. Then there are new requirements arriving. Imagine you are an OEM or a tier 1. You need to look for a partner to help you with that. If your partner, technology partner, semiconductor supplier, is only offering you one piece of the puzzle, you might be limited in your developments. And that's where I think Infineon provides really benefits to our customers. Having all the different technologies, the packages we talked about, we can combine things, and we have the control on top of that with microcontrollers, gate drivers, and sensors.
We're talking about innovation. I would suppose this is a topic for a podcast by itself. So you both mentioned Infineon's vision 10-100. Well, do you expect to come this real? And most of all, when will this become real?
It will come real. I'm quite sure about that. So there are already a handful of cars in that range. Yeah, not too many. The average is still 15 to 20. But there is already proof of the idea that it can get reality. And certainly you need to find the right ways to do that. We talk about size, air track, weight optimization. All that comes back to using the right technology on the power switches, for example, and putting that in a whole system, a holistic thinking.
Yeah, exactly. So I think, of course, we have to get it in conjunction with the WLTP, right? So, of course, it's 10 kilowatt hours per 100 kilometers in the WLTP. Yeah, just because, of course, if we are going too fast with our electric cars, the air drag is so dominant that you cannot achieve it. But very important is that we are efficient where the most kilometers are driven, and that's, let's say, according to the WLTP, and that's completely fine. And there we can get it.
Perfect. Sounds like a great future ahead of us. Thanks, Dirk. Thanks, Christoph, again. This concludes our electrifying episode about electric vehicles. You've noticed there's much more to come. Stay tuned with our podcast for engineers.